Okay, and let's go from current slide. Okay. Okay. All right. We'll pick up at the beginning of the problem we left off with last Wednesday. Again, let me ask, any questions, problems, issues, concerns? Okay. Let me go over a couple things first. I imagine you realize this, but I don't know for certain that you do. It's sort of a good news, bad news situation. Y'all know what I'm talking about or not? Okay. The good news is Wednesday is Veterans Day. And the state of Alabama, I think, unlike most of the other states I know, has this as a state holiday. Okay, meaning no one will be either on campus or participating in campus activities on Wednesdays because it's a state holiday. There will be no classes, nothing. Now the bad news is that means we won't have class on Wednesday. So today is it for this week. Now, of course, I hope you know also next week is the week before Thanksgiving, and then the week of Thanksgiving there are no classes, or at least that's what my understanding is. In the past, we've had professional meetings Monday, Tuesday, and Wednesday before Thanksgiving, and then of course Thursday and Friday are holidays, state holidays. So I assume that's how they're still going to do it now with COVID and everything else going on. So we have one class this week, two classes next week, then we have the week of Thanksgiving off, then we have two classes on the first week in December, and then that Wednesday of that class, the first Wednesday in December, I'll be giving you your final exam, and that's due whenever you can get it into me, preferably Monday of the following week, but anytime that week. Now, neither of you are graduating this term, are you? Yes or no?
No, sir.
Okay, neither one of you are. I don't know about the other two. But if you are graduating this term, then it might be a little more necessary for you to hustle up getting your finals in so I can get your grades into the registrar's office in good time. But if you're not, just get them into me sometime during final exam week. Which means, of course, research papers. I can't remember who's done which one in here. I think maybe I've only received one. I may not have all of them graded yet and posted on Blackboard. Some of them may be graded but not posted or whatever. But please don't forget to do your research paper. Preferably this month, the month of November, you get that one bonus point left over. But if you get it to me that first week of class, the only week of class that we have in December, then you just get your score. If you get it into me during final exams week, you start losing points. So please get it in this month so you can get that one remaining bonus point. All right, any questions, problems, issues, concerns with anything I just said? Okay. We have progressed through example 3, and I'll go over a little bit of that just to review because that was, I know, a long time ago. But this is a rational expression. We're integrating a rational expression. A rational expression means it's a ratio of a polynomial in the numerator and a polynomial in the denominator. Now they got halfway through doing something good for you here, and it's pretty nice that they did that. They partially factored the denominator. It really doesn't matter too much about factoring the numerator, except as we did, I suggested we factor out the 2. I don't know why they, well, anyway, I would factor out the 2. I don't think there's anything else you can factor in the numerator, but I would do that. If you can factor the numerator, and one of the factors in the denominator is the same as one in the numerator, you eliminate it, okay? That's one thing they haven't emphasized, but they'll sneak up on you and trap you with one of them. But the main thing is to factor the denominator. They've partially done that, but not completely, because this first factor here can be factored further. That's x times x minus 1. The second factor cannot be factored any further. That's x squared plus 4. You can never factor the sum of two perfect squares. Difference of two perfect squares, yes. Sum or difference of two perfect cubes, yes, but not the sum of two perfect squares. So this is a linear factor. That's a linear factor, and this is what they call an irreducible quadratic factor. Okay? Now we've gone through the work, and I'll show you again. And we'll probably run out of room because they tend to do that. What you have is 2 times x cubed minus 2x plus or minus 4, factoring out the 2, divided by x times x minus 1 times x squared plus 4. Now, I'm all in favor of just taking this 2 outside the integral here and leaving that to be a 1, a minus 2, and a minus 4. Okay, it's a little ugly and sloppy, but it's not too bad. Okay, it will, I think, help you out a little bit later. Okay, now what we do here is break this denominator into the partial fraction form. And I meant to say this earlier. Before you go any further with this integral, make sure that it is a proper rational expression. What that means is that the degree of the numerator, which is the highest exponent in the numerator, 3, is less than, not just less than or equal to, but less than the degree of the denominator. Well, then, if you had multiplied these through, you see that you'd have had x squared times x squared is x to the 4th. That's greater than x cubed. We're in good shape. All right, now we're going to do the partial fractions of this denominator. The first is a linear factor, so its coefficient is just going to be a constant, a over x, plus this is a linear factor, so that's just going to be a constant, b over x minus 1. But this is a quadratic, an irreducible quadratic factor, so that means its numerator has to be a linear factor, cx plus d over x squared plus 4. Always the numerator is 1 degree less than the denominator. Now, it could turn out, it's quite possible, that c could turn out being 0. That's fine, but you always consider the possibility, and for some reason my nose is itching like crazy, and it's probably going to have a sneeze coming on sometime soon, which I know y'all love, but can't help it. I don't know what's going on. All right. Then what we do, as we always do, is multiply through with that denominator. So we'll multiply here by x times x minus 1 times x squared plus 4. I know this is getting messy. We'll multiply here times x minus 1 times x squared plus 4. And we'll multiply it here by x times x minus 1 times x squared plus 4. And we'll multiply over here, this is already a binomial, times x minus 1 times x squared plus 4. Whew, done. Okay, now we'll deal with getting rid of denominators. That's why we multiplied by that. Here the x's go out, the x minus 1's go out, and the x squared plus 4 goes out. That's what we wanted to see happen. So here we have in our numerator x cubed minus 2x minus 4. Now the book keeps that 2 in there. I've already factored it out. Don't forget it's out there. Okay. Now here we're going to divide out the x, and that gives us a times x minus 1 times x squared plus 4. Okay, good for that. Here we're going to factor out the x minus 1, and this gives us plus b times x times x squared plus 4. Here the x squared plus 4's go out, and that leaves us with, I forgot my parentheses. I wondered where that came from. Plus c x plus d times x minus 1. We're almost out of room. Okay, then we do our little trick. We pick values of x, because this is supposed to be good for any values of x. We pick smart values of x that are going to help us. Okay, and one that seems pretty promising is put x equal 1. So we'll put x equal 1. And when you do that, this becomes 1 minus 2, that would be a minus 1, minus 4 is a minus 5. Okay, it's equal to, and when x is equal to 1 here, that goes to 0. When x is equal to 1 here, you get b times 1 times 1 plus 4 is 5. So that'll be 5b. Okay, and over here, when you put x equal 1, that one goes to 0, means the whole term is 0. So that leads us to understand that b must be a minus 1. Because if 5b is equal to negative 5, divide both sides by 5, and you get b is equal to minus 1. So we've got our b term. Well, let's pick another value, a good value for x. Why not 0? That's going to come in pretty nicely. X equals 0. Well, that's going to be pretty nice here, because this is going to be a 0. That's going to be a 0. This will be a minus 4 is equal to, and if x is equal to 0, this will be a minus a times 4. So that's a minus 4a. And if x is equal to 0 here, that's going to be 0. X equals 0 here, that will be 0. So that leads us to understand that divide both sides by minus 4, a is equal to 1. All right, now we've used up all our easy x's. Okay, we can use more x's, and that's about where we left off before. Nothing is going to become a 0 and make it really easy for us, but we can use other x's. For instance, if I could get my pen to show back up. Where are you, pen? There it is. Okay, let's let x equal, say, minus 1. Okay, so this will be minus 1 plus 2, that would be a plus 1, minus 4, this side would become a minus 3. Check my work and make sure I've done it right. Okay, and minus 3 is equal to, now we already know what a is, so don't be carrying around the a anymore. Make that a 1. So that's going to be a 1 times minus 4, because minus 1, I'm sorry, that's minus 2. I can't read. Oh, that's not what I want. It's this one. I can't get it to show up. Yuck. There it is. Okay. Okay. X equal minus 1. A is a plus 1 times minus 1 is minus 2, and minus 1 plus 5 is, I'm sorry, plus 1, because minus 1 squared is plus 1, plus 4 is 5, and this will be a minus 2, so that's minus 10. Well, I've got to get my pen back. Okay, minus 10. Okay, here we have, when x equal minus 1, this will be a minus b, and then this is another plus 5 again. So that would be minus, oh, b is minus 1. So minus 1 times a minus 1 is plus 1 times 5. So that's going to be a plus 5. And finally, this one will be a minus c. Well, let's plug the rest of them in. There's a minus 1, and that's a minus 2. So that multiplies to be a positive 2 times a minus c. So that's going to be minus c and plus 2b, or not 2b. Okay, so what does this give us? If you add 10 to both sides, that gives you a 7. Subtract 5 from both sides, that gives you a 2. So we have an equation here, 2b minus c is equal to 2. Now, at least that's what I think it is. Where did I get b's from? I wrote this as a b rather than a d. That's sort of dumb. I was saying we don't have another b in here. This is a d here, and that makes this a d. Okay, so d here, and that makes this a d here, and it makes that a d that I forgot to erase. Oh boy, the old gray cells aren't working too well today. That's a D. Okay, now let me check that. No, it's not right. Goodness gracious, the brain's not working well. Not working at all well. Let's try this again. X equal minus 1. Now maybe that's one of, yeah, x equal minus 1. A is equal to 2. Oh, I know why. Okay. Part of the problem is I factored out the 2. Okay. So we may have different answers here. But let me go back and check my work here. Okay. Here, when we put in x equal minus 1, we got a minus 1 plus 2 would be a plus 1, minus 4 is minus 3. So that one should work. Here with a equal 1, which I think we, yeah. Now, when they did it, they got a equal 2 and b is equal minus 2 because they left the factor of 2 in there. We took it out. So a is equal to 1, and x equal minus 1, this would be a minus 2a, and this would be a 5, so that's minus 10. Okay, but a is 1, so minus 10, that one's right. This one would be b is a minus 1, x is a minus 1, that gives you a plus 1 times 5, which would be plus 5. And then this one, let's make sure we did it right. X is a minus 1, so that's a minus c times a minus 1, that's a plus c, times a minus 2, that's a minus 2c. Now, that's where I think I made a mistake. So, let me go back. Y'all should be correcting me on things like this. I'm going to erase some of this. Okay. Let's try that again. All right. Sorry about this. I have had, sorry, I know you get sick and tired of hearing this, because I actually get sick and tired of being sick and tired. But boy, this weekend I just had no energy at all. I think the anemia, of course, I was doing some work. We went up to my wife's parents had bought a place up at Smith Lake way before I was in the family, and we are now sort of caretakers of that. They wanted to get out of the house because they live in Huntsville and they're just sick and tired of being stuck inside. So we went up to the lake, and they had a pretty good time. I had a good time too, but I basically worked the whole time I was up there, and I'm just exhausted. Okay, this anemia is just getting to me like crazy. Okay, enough of that. So I think what we had here, if I can find my pen again, there it is. Minus 3 is equal to minus 10 plus 5, and here's where I was having difficulty. When x is a minus 1, which is what it is here, then we have minus c times a minus 1 is plus c times a minus 2, minus 1, that gives you a minus 2c, I think. Check my work there, okay? And then the d part, this would be a minus 1 times a minus 2, that would be a plus 2d, which still looks wrong. Minus 1 times a minus 2, that's plus 2d. Now something is amiss here. Well, wait, let's carry it on out, okay? Well, like I said before, let's add 10 to both sides. That gives you a 7. Subtract 5, and that gives you a 2, okay? And that gives you a 2 is equal to minus 2c plus 2d, which of course you can then divide out the 2's and have minus c plus d is equal to 1. And I think that's what they got. Yes, okay. So we got that far last time. We're running out of room though, so let's try one more. Let's let x equal 2. That seems the next one we've done, 0, plus 1, and minus 1. Let's let x equal 2. Okay, so here we get 8 minus 4 minus 4. So that looks like that's going to be a 0 on this side. Okay, check my work again. 2 cubed is 8, minus 4 is 4, and minus another 4 is 0. So 0 is equal to, and what do we have on the right hand side? Okay, a was 1 times 2 minus 1 is 1, so you got a 1 there, and then you have a 1 times 1 plus 4 is 5. So on this side we have a 5. Here, when we put in a b is equal to minus 1 times 2, that's going to be minus 2 times, and this is again 5, so that's going to be a minus 10. That looks sort of familiar, doesn't it? Okay, and here we have b is equal to, x is equal to 2, so you have 2c times 2 would be 4c times a 1 would be plus 4c. Okay, and then for the d term we have d times 2 minus 1. 2 times 1 is 2. It's plus 2d. Okay. All right. Let's take care of that one then. This would be a minus 5. Add that to both sides, you get a plus 5. I'm not getting the right answers. Okay, I'm sorry. The old gray cells are not working well today. So let's go back here and check again. X equal 2, that would be 8 minus 4 minus 4. I think that's a 0. I sure hope it is. Here we have A is equal to 1 times 1, that's 1, times 4 plus 4 is 8, not 5. Oh man, I was doing the last one. Goodness gracious, this is going bad. This is an 8 here. I bet you botched up something there too. Let's just see. All right. Then the next one was X equal 2. That was there. B is equal to minus 1. X equal 2. That would be a minus 2 times 8, right? 2 squared is 4 plus 4 is 8 times a minus 2 would be a minus 16. Okay. All right. Now let's try the next one. Okay. 2c, x equal 2. 2c times 2 would be 4c times 1 would be plus 4c. Got that one. And this would be 2d times 1 would be plus 2d. Okay, so this will be a minus 8. Add it to both sides. That gives you a positive 8 on this side is equal to 4c plus 2d, which if you divide everything by 2, you get 2c plus d is equal to 4. Let's see if that's what they got. They got 8, but I think that's because they still have their 2 in there. I sure hope so, because I don't want to go through that again. So let's see what we've got if we put this in place. 2c plus d is equal to 4. Okay, I hope that's right. It looks like it is. Okay, now let's solve for this. I would suggest subtracting the top equation from the bottom equation. Okay, down here, pair of equations. That would give us 3c is equal to 3, so c is equal to 1. Okay? Okay? And if c is equal to 1, plug that in here, you get a minus 1 plus d is equal to 1. So d is equal to 2. And okay, I think we're okay with that one too. We'll see. Okay, so what we've got to do is go back. I think what I need to do is erase a bunch. Okay, let's get rid of that because we've already used it. Okay, and this. Okay, and a lot of this. And I hope I can get rid of the other. Now if I made a dumb mistake and I've already erased it, y'all gonna have to find it. I'm just okay, so let's get rid of this too. Okay, we'll get rid of this one, and someplace down here we'll stop erasing. Not quite yet, but somewhere down here we will. And And it looks like a good place would be right here. Okay. All right. A is equal to 1, B is equal to minus 1, C is equal to 1, and D is equal to 2, I hope. And again, if I'm wrong there, y'all, oh, I erased more than I meant to. Okay, but I think I can remember how it worked. So let me get my pen back. All right, so what we have here is this integral becomes 2 times the integral of, and I have to remember what it is. Was it a over x? Was that right? Was that what the a was? My memory is that it was, but yes, it was. Okay, dx plus the integral of b over x minus 1 dx plus the integral of c, oh, I'm sorry, wait. That's a minus there, okay, because the b was negative. Almost blew that one, okay. The b was minus 1, okay. And plus c was 1, so that was x plus 2 over x squared plus 4 dx. Now that's what I recall. Okay, why in the world I wrote the a's and b's here, I don't know. This is 1 over x, and that's minus b. Sorry about that. Okay, the old gray cells. 1 and 1 here. Okay, so what do we have? We have 2 times the integral of 1 over x dx is log x minus the integral of 1 over x minus 1 is log of absolute value x minus 1. And probably we should put this as absolute value also. Okay, plus, now this one might take just a tad more work, but I think we're probably going to be okay with it. I think what we probably need to do with that is break that into 2 integrals. Okay, the first integral is going to be x over x squared plus 4 dx, and the second integral will be plus 2 on the integral of dx over x squared plus 4. Okay. Remember that the 2 is outside all that. All right. Here we have 2. And I'm going to go on and write this as log of absolute value x over absolute value of x minus 1, which I think we could put all in one absolute value. That would make a lot of sense. Okay, plus, okay, now in this one I think a u substitution looks to be appropriate. Let u equal x squared plus 4. Then du is equal to 2x dx. Well, we don't have a 2x up here, we have just x, so let's divide everything here by 2. So this would be plus 1/2, that's where the 2 went, the integral of du over u. Okay, which is going to be another log, I think. Okay. Now that last one, plus 2. Now that, to me, is looking a lot like a trig substitution. Okay. So here we'll let, and that looks like a tangent. So it will be 2. Let's see. Let me write this as tangent theta is equal to no, I'm sorry. Getting my trig substitutions crossed up. The brain is not working well this morning. Okay. Okay. Let x equal, that's it, x equal to tan theta. All right. And there's a bunch of thens, two thens that come after this. First, we're going to square both of those. X squared is equal to 4 tangent squared theta. And then add 4 to that, and you get x squared plus 4 is equal to 4 tangent squared theta plus 4. And that becomes 4 times tangent squared theta plus 1, which is secant squared theta. Okay, so that's the first of those. The second of these thens is x is that, then dx is equal to 2 times secant squared theta, because derivative of tangent is secant squared theta. Okay, now, all right, with those in mind, that integral becomes 2, there's the 2 there, times the integral of, and then the numerator, your dx, is 2 times secant squared theta, so that's going to be a 4 out here, secant squared theta here. I needed to put my d theta following that because always the d's go together. Okay, divided by, and that x squared plus 4 became 4 times secant squared theta. So that 4 and this 4 cancel out, and you're left with a secant squared theta here, and that's just a 1. Okay, so this really simplifies to be the integral of d theta. Okay, we'll come back to that in a moment. Okay, well, let's just write it down now. Plus theta. Okay, so what we have here is 2 times the log of absolute value x over x minus 1. So we'd simplify that a little bit. This 2 times the 1/2 basically goes away, but you've got your u substitution here, and that would be plus log of u. Okay, but what was your u here? X squared plus 4. Log of x squared plus 4. Now there we don't need absolute value bars because x squared is never negative or 0. Well, x squared could be 0, but add 4 to it. It's not. Neither could be 0, so you're okay there. And then this one, our trig substitution, let x equal 2 tangent theta. That means that tangent theta is equal to x over 2. So theta is equal to the inverse tangent of x over 2. So this final one would be inverse tangent that's a minus 1, inverse tangent of x over 2. And then we have our plus c somewhere out there. Okay, well, we don't need the bracket. Let's see how close we got. They kept those together, so they have 2 log absolute value x minus log 2 log absolute value x minus 1 plus log of x squared plus 4 plus, they have a 2 arctangent. Oh yes, I'm sorry, I forgot that. This 2 is still in front of that one, so that is a 2 inverse tangent of x over 2, and then you have a plus c. Yep, got it. Sorry about that last 2, went that far. So, any questions on that? Sorry about a couple of errors there, but let's clear the screen here. Any questions before I clear it? Okay, and we're going to see how they did it. Now, they did not factor out the 2. I don't know if that's better or worse. I don't think it's as good, but obviously because I didn't. But they did factor the denominator to be x times x minus 1 times x squared plus 4. One partial fraction for each of those factors. That would be a over x plus b over x minus 1 plus cx plus d over x squared plus 4. Always the numerator was 1 degree less than the denominator. Okay, unless you have a multiple denominator. We've already hit those before. Okay, now multiplying by the least common denominator, which is that, and yields the basic equation. The numerator, 2x cubed minus 4x minus 8, leaving the 2 in there, is equal to a times x minus 1 times x squared plus 4 plus bx times x squared plus 4 plus c x plus d times x minus 1. Alright, sorry folks, I've got to get some more caffeine, sugar, something. I'm about to lose it. It is an unbelievably beautiful day out there. Maybe that's where the other 2 are. I don't know. It was 78 degrees, I think, when I went down to put the dog out. And so it's really gorgeous looking out there. It was very windy this morning, but it's not anymore. So I shouldn't be talking like this. Y'all want to leave. Never mind. I want to leave. Never mind. Alright, so there's your basic equation. You got rid of all the denominators by multiplying by the least common denominator. Okay, now, first thing, pick the easy values for x to plug in. That would be x equal 1, x equals 0. Okay, those will be the easy ones. And when you do that, to solve for a, let x equal 0, and you get a is equal to 2. Now we got a is equal to 1 because we factored out the 2. Okay, you'll see every one of their a's is twice what ours is. So when you go back and factor out the a, basically we're factoring out the a. Our a was 1. To solve for b, let x equal 1, and you get b is equal to minus 2. We got b is equal to minus 1 because we factored out the 2. Okay, at that point, C and D are yet to be determined. You can find those remaining constants by choosing 2 other values for x and solving the resulting equation, a system of linear equations. And if you let x equal minus 1, your a is 2. We had, well, let's just forget that for now. X equal minus 1, a is equal to 2, which we just did, but we used a is equal to 1. B is equal to minus 2, which we used b is equal to minus 1 because we had already factored that out. But when you do that, you get minus 6 is equal to, and they use that basic equation, and without having it in front of us, that makes it a little hard to see. Negative 6 is equal to minus 20. This is why if you have factored out the 2, the numbers are much easier, and that would be a plus 10 plus a negative c, well, a positive 2 times a minus c, so that would be minus 2c plus 2d, okay, which yields us a 2, okay, because you're subtracting 20 here, so you add 20 to both sides, you get a 14. Here we have a 10, so you add or subtract 10 from both sides, and you get 4 then. So 4 is equal to minus 2c plus 2d, and then divide everything by 2. Okay, so they get that as the first equation. Then plugging in an x equal 2, you could choose any number, but keep them as small as possible. That gave us 16 here, and this gave us a minus 32, again because they use such large numbers, and that gave them a 2c, so that gave them a 4c plus 2d. Okay, so here this would be a minus 16 plus 32. That would be a 16 is equal to 4c plus 2d. Divide everything by 2, you get 8 is equal to 2c plus 4d. Now we have two equations with two unknowns. I would subtract this one from that one. That gave us a 6 is equal to 3c. So c is equal to 2, and then when you plug that back in here, that would be a minus 2 plus d is equal to 2. Add that everywhere and you get d is equal to 4. Now, they didn't factor out the 2, so they have 2's everywhere here. And if you did it now, that would make more sense. I think they finally do get around to doing that. 2 over x minus 2 over x minus 1 plus 2x over, now you see they went on and broke the second one down, that last integral down into a 2x plus 4 over all over x plus 2. They broke it into two pieces. Now when they do that integral, you get 2 times the absolute value of x minus 2 times absolute, 2 times log of absolute value of x minus 2 times log of absolute value x minus 1. And then this one becomes a, without showing you how they got it, a u substitution gave it to us, plus log of x squared plus 4. And then this one, without showing you how they got it, it gave you 2 times the arctangent of x over 2 plus c. And that's how they leave their answer, I think. All right, that was the end of example 3, which took a while to do. Let's move on to example 4, which they don't do in the slide set. So let's back up one and do example 4. Go to our whiteboard. All right, sorry folks, I'm so tired, it's just amazing. All right, I'm going to move this up here. You can't see what I'm talking about, but it's a taskbar for doing the whiteboard, and since I don't want it in front of the whiteboard or in the whiteboard, so I can have as much white space as possible. Okay, I think I've moved everybody else. Now, we haven't heard from the other two guys, have we? Let me just check and make sure they're not out there waiting. No, they're not. This is unusual to have only half the class here. Most of the time the full class is here, but I guess we're stuck with it. All right, now I'm going to need to put my book in my lap, at least to begin with here. So here's what we got. If I could get the pen, there it is. Okay, the integral of 8x cubed plus 13x, that looks like a very promising set of a numerator, divided by x squared plus 2 squared, okay, dx. All right, now the first thing we do is make sure that we have a proper rational expression there. Okay, degree of the numerator is 3, but the degree of the denominator is x squared squared. That's going to be x to the fourth, degree 4. That is a proper denominator, a proper rational expression. So we're okay to go. All right, so what we're going to do next, I think I'll do it down here. This is an irreducible quadratic expression, but it's squared, okay? So our numerator is still 8x cubed plus 13x over x squared plus 2 squared. There comes somebody. Brandon. I think I got him in. All right. Brandon's here. So now we're just missing Ashton. Y'all haven't seen or heard from Ashton, have you? Make sure he's not out there. I don't see him. Okay. Brandon, we're doing example 4. We're in chapter 8, integration techniques and improper integrals, mostly doing integration techniques. We're in 8.5 partial fractions, and what we've got so far is this. We've determined that is a rational expression, and we're breaking this into the partial fractions that it needs to be. Now, the only way to split this, because that's an irreducible quadratic expression, but it's squared. So what we do, we have first that thing to the first power, x squared plus 2, okay? And the second partial fraction is going to have the x squared plus 2 squared, okay? Now, the numerator for this one, because that is a quadratic, is going to be ax plus b. But the numerator for this one, because it's a quadratic, but it's just that it's raised to the second power, that's still a linear form, which is cx. I'm so sorry. I don't know where that's coming from, but it's coming. Can't do anything about it. Sorry. I guess y'all are awake by now, right? Plus d. Both are linear factors because your basic denominator is a quadratic. Okay? So, what are we going to do? Just as always, multiply by your least common denominator, which is your x squared plus 2 squared. This will be multiplied by x squared plus 2 squared. And this will be multiplied by x squared plus 2 squared. Now the good news is all your denominators disappear. That one goes into all of that one. One of these, you only got one, goes into one of those. And this one, both of those go into both of those. All right, so your basic equation, that's what they call it now, is 8x cubed plus 13x, because both of those went out, is equal to, and here we have an ax plus b times an x squared plus 2. And here we have a plus cx plus d times, no, it's just cx plus d, sorry. Okay. Oh, I'm in the wrong. These different screens have different eraser mechanisms. Okay, now basically what we got to do is multiply, FOIL these two binomials. So that's going to be an ax cubed. Ax times x squared is ax cubed. And let's do our squared terms next. Plus bx squared. Okay. And then our linear term next. That's going to be plus 2ax. Right? And then our constant term last, and that's going to be plus b 2b, or not 2b. B times 2 is 2b. Okay. And then over here we're going to have a plus cx plus d. And over here we have our a 8x cubed plus 13x. Now, I guess that you could choose some x equal numbers and help out with this a little bit, okay? However, in this case, I think it's easier just to look at common terms, okay? Here we have the only two cubic terms. This basically tells you a is equal to 8, because 8x cubed here has to equal ax cubed there. There aren't any more x cubed terms. So we already know one of those. Now, there aren't any squared terms over here, which indicates to me that b has to equal 0, because there's a bx squared here, but there is no x squared here, so b has to equal 0. Now let's look at the linear terms. Okay, this is 2 times a, which is 16x, plus c times x, and that has to equal 13 because that's your x term over here. So it looks like to me that c has to equal -3. All right, and then we've got that 2b, which is 0, plus d has to equal 0, so this d also has to equal 0. Okay, now if I did that right, I think that's what we've got. Your b and your d are 0, okay, and your a is 8 and your c is -3. So let's go back to, I was going to write it up here, but now that big black rectangle's in the way, so I'll have to write it down here. That integral we started with, and to keep me from having to write it, remember what it was, ax plus b over this. So a was 8x, and there is no b, okay, 0 would be. So this is over x squared plus 2, okay, yeah, right there it is. Ax plus b, a was 8, the b was 0, so it's 8x over x squared plus 2 dx, okay, plus the c is a -3, so let's make that a minus, okay, -3. I wish I had pulled the 8 on the outside too. And what do we have? X, d was 0 over x squared plus 2 squared, okay, dx. All right, now both of these lend themselves to be, if I'm not mistaken, u substitutions. Let me make sure I'm looking at it right. I believe so. So let's do our U substitution here. This one I'm going to pull a 4 on the outside and leave a 2 on the inside, because if you do let U equal 2x, no, x squared plus 2 from that denominator, then du is equal to 2x dx. Alright, so that's why I left a 2 in there, 2x dx, numerator over u in the denominator. So that's going to be a 4 times the, and this will be du over u, which is log u. U is x squared plus 2. That's the log of, you don't need the absolute value bars, x squared plus 2. Okay, now we'll work on that in a minute. Plus, folks, I'm about to lose it. Hold on. Okay, I hope you don't mind me using another U substitution. You could call it V, but if you're not going to be confused by it, it's actually the same U. Okay, U equal x squared plus 2. Du then is going to be 2x dx, just like it was here. We don't have a 2x dx, we have an x dx, so this time we're going to divide by 2, and that will give us a 3 minus 3 halves down there, and then this will be your du. So you have the integral of du over u squared. Okay, so let me write that one here, the integral of du over, well, let's write that as u to the minus 2, because that's what you had, u squared, which is 1 over that, and that's an integral, not a log, but this is going to be minus u to the minus 1. Okay, and we'll have a plus c with it. But u is x squared plus 2. So the second part of there is minus now. I put a plus. That should be a minus now, if I can find where my eraser is. Okay. I'm sorry, I'm so congested I can hardly think. 3 halves. One of the things I was doing this weekend, the whole weekend it seemed like, was burning some brush and stuff like that, so my head is all messed up from that. Sorry. Okay, so that's well, first did it backwards. This was a minus, but then that's a minus, so that actually makes that go back to being a plus, and the u is the x squared plus 2, so that would be that over x squared plus 2. Okay, and then we have our plus c, of course. Alright, let's see if we can, I don't know, that looks good enough to me. I don't know how they wound up putting it in the book. See if I can find it. 4 times the log of x squared plus 2, got it, plus 3 halves, and yeah, they have it basically the same way I have. 3 over 2 times x squared plus 2 plus c. Yeah. Now, they show a technology blurb there using a graphing utility, confirm that the decomposition found in that is the same, and you add those two together and you get a form that looks like that. Now the interesting thing there is that looks like a oh, I see what they did. But it looks like it's an odd function, and indeed the numerator is odd divided by the denominator, which is even, but an odd divided by an even is odd, strangely enough, but that's true. Over here, it's not as obvious that this is an odd function here, because you usually don't think of log as being odd, nor do you think of that. So it just happens to be, it does turn out being odd. And oh, I'm sorry, what they did, their graphing thing was only looking at the integrands. It wasn't looking at the answer. Okay, sorry. That's why the answer is not necessarily an odd function. Sorry, I shouldn't have even brought that up. Okay, any questions on that before I clear the drawings here? And we'll go back to the PowerPoint. Let me make sure that, nope, nobody's waiting. And we'll go back to the PowerPoint. All right. Now, go back to resume the slideshow. I don't know why that one popped up. Okay. Now, we finished example 3 before. We just did 4. Here are the guidelines that they list on page 556. Okay. Now, they did finally get around to talking about what you need to do to integrate rational functions. Keep in mind that improper expressions have to be made into proper first. So I should have left my whiteboard up there and just erased the screen. I guess I did erase the screen. I had forgotten I did that. So what if this was your integrand? Okay, 2x cubed plus x squared minus 7x plus 7, okay, divided by x squared plus x minus 2. Okay, now I'm going to tell you what I'm going to do first. Okay, I'm going to factor that denominator. Okay, I know that it's not going to get me anything, but I want to factor it. Okay, so that'll be x times at x plus times a minus. The 2 is with the plus and the 1 is with that. Now the reason I did that, I want to make sure that x equal 1 is not a solution making that numerator go to 0. In other words, x minus 1 is not a factor of that. So let's try it. Okay, I mean x equal 1. So put a 1 in there. You get 2 plus 3, plus 1 is 3, and then you get a 0 here. That 3 is not equal to 0, so that's not a factor. How about a negative 2? X equal a negative 2. Well, that would be a negative 8 then. 2 times negative 8 is minus 16 plus goodness, my brain's disappearing. Plus 4, because we were doing x equal minus 4. So negative 16 plus 4 would be a negative 12 plus 14. That would be a minus 2. No. Goodness, my brain's not working. So let's do this. That would be a negative 16 plus 4 minus 14 plus 7. Obviously that does not add to 0. Okay, so I always like to check and make sure that there's no common factors there. This looked like a bear to try to factor, so this was easy to factor. Just plugging in a -2, that doesn't give you a 0. Plugging in a +1, that doesn't give you a 0. Okay, so here's where the book starts out. We take the numerator, okay, remember the rule was know that the numerator cannot be a degree larger than cannot even be equal to the same degree as the denominator. It has to be less. Well, here it's greater. So what we're going to do is long division. So that's going to be x squared plus x minus 2 divided into 2x cubed plus x squared minus 7x plus 7. Okay. Now, when you do long division of polynomials, you have to make sure you do not leave out a term. Here, count your numerator, your exponents. 2, 1, 0, all accounted for. 3, 2, 1, 0, all accounted for. So we're in good shape. Now we do our division. X squared will go into 2x cubed, 2x times. Okay? Multiply 2x times x squared is 2x cubed, and 2x times x is plus 2x squared. Okay? Then subtract or change signs and add. That gives you a minus x squared. Bring down 1, minus 7x. Okay? X squared will go into x squared to a minus x squared, a minus 1 times. Okay? 1 times x squared is minus x squared. I left off a term, didn't I? I multiplied this one and that one, but I forgot to multiply the last one. Let's say minus 4x. Sorry about that. Like I said, the old gray cells aren't working today well at all. Okay. Okay. 2x, that would be 2x cubed plus 2x squared minus 4x. So we subtracted these two. When you subtract this or change signs and add, that's going to be a minus 3x, and then bring down the plus 7. Okay. And then when you multiply that, you get minus x squared minus x plus 2. Goodness, my pen's not writing. Okay, when you subtract these, that goes away. And this gives you, change signs and add, that would be a minus 2x plus 5. Okay, this is a degree less than that, so you're in good shape. So you put minus 2x plus 5 over your denominator, which is x squared plus 2 plus x minus 2. Now, this integral here, though they don't list it as an integral, what this produces for you is 2x minus 1 minus, now I sort of messed that up a little bit. I'm going to put it this way, plus, and I like it better the other way, okay, You have to watch your minus signs here. They're only there to trip you up, so be careful for them. I should have written this, because that was a minus 2x plus 5. I should have written that as a okay. There we go. Okay, I can't get that. Okay, that gives us what we had before. Minus 2x plus 5. That's your denominator over this. So that's a minus 2x minus 5 over x squared plus x minus 1. And then what you do here, when you integrate this, that's just x squared minus x. And then when you integrate this, that is a partial fraction, x, just like we did here, x plus 2 times x minus 1. So you have a over x plus 2 plus b over x minus 1, and then work through those just like we did before. This one, you just integrate that dx. Here we do the partial fraction integration there. They don't carry it any further, but that's exactly what we've got. They left that as a minus 2x plus 5. I pulled out the minus sign and went with that. Okay, now we're ready, I think, to go back to our, let me make sure that we don't have Ashton out there waiting. No, we don't. 8.5. Okay, Ashton's not there yet. Okay, and we need to go back to current slide. Okay, here are the guidelines for solving the basic equation that is obtained from partial fraction decomposition. Okay, now I think they've still left off the important things, some of the important things. Number one, they just jumped to the basic equation. I think what they should do is also have in here, before you get to the basic equation, make sure that you have reduced your improper fractions to proper fractions. Do that first. Look at your degrees of the numerator. It's got to be less than the degree of the denominator. If it's not, divide, just like we did in that last sort of partial example. Okay. Now, once you get it into a form like that, that is in proper rational expression, then see if you can divide, factor your denominator. And the point is, you always can factor the denominator. They may not be pretty factors, but you can get them down either into linear factors or irreducible quadratic factors. That's the only thing we have to have, and they have to be one of those. Okay? Now, if all those, that basic equation you got has linear factors in it, then substitute the roots of the distinct linear factors into the equation to make it easier to eliminate. Okay? For repeated linear roots, use the coefficients determined in the first guidelines to rewrite the basic equation. Now, what do they mean by that? Okay? Remember, these are linear factors, so it's going to be a over x minus 3 or something like that, plus b over x minus 3 squared, plus c over x minus 3 cubed, as many as it takes for repeated linear factors. As long as you got another repetition coming there, you keep the numerator as being a zero order, and the denominators go up until you reach your k. Okay, but numerators are all linear. I mean, zero degree. Okay, constants. Then substitute the other convenient factors in for x and solve the remaining of the coefficients. Okay. Now, when you have quadratic factors, it says expand the basic equation. Okay, what they mean for that is if you have an irreducible quadratic factor, then it's going to be underneath a linear factor. Okay. Now, when you do the expansion, collect terms to powers of x. And that's what we did in that last one. When you can do some of your substitutions, do them. Okay. Let x equal 0, x equal 1, or negative 1, or something like that. As long as you can eliminate some of those quadratic factors, do so. Okay. Or some of the constants. Figure out what they are, easily do it. But at the end, you usually get to the place that you can't do it any longer. Expand the basic equation, collect the like terms according to powers, equate those coefficients of like powers, just like we did, what was that last one? It was ax cubed is equal to 8x cubed. Well, obviously a is equal to 8, okay? And then you had a bx squared, but on the other side there wasn't an x squared, so b had to be 0. So collect the like terms according to the power of x, equate the coefficients on like powers on either side of the equation to your a, b, and c, and then solve the system of linear equations. Sometimes you could get some pretty hairy systems there. Most of the time it won't be a big deal here. Now, I think I just heard someone at my front door, but I will check on that after class. How are we doing on time? Okay, we got a little bit of time left. Okay, and solve the system of linear equations to figure out what the a, b, and c are. All right, and that ended the slideshow. They do have a little blurb at the bottom of page 556. It says, before concluding this section, here are a few things you should remember. First, it is not necessary to use partial fraction technique on all rational functions. For instance, the following integral is found more easily using the log rule. If it works out for you, that works directly, use it. Okay, you don't have to use partial fractions. Second, when the integrand is not in reduced form, reducing it may eliminate the need for partial fractions. And that's the one I was talking about. If you have common factors, get rid of them. Most of the time, they will mention that early on rather than holding it off to the very end like this. And it says, finally, partial fractions can be used with some quotients involving transcendental functions. So if you have, say, trig functions or other functions, and you can treat those as, say, a u function and do partial fractions with those, that's perfectly fine too. I didn't find that was all that yeah, my wife just sent me from work because she has Ring on her phone that somebody made a delivery, so I know that. I'll get that as soon as I can get down there. Okay. All right, sorry about that. So let me show you, I guess, that last couple of things they were doing there. And this is important. I just wish they hadn't waited till the very end to mention it. Usually your textbooks will mention this much earlier. Okay, here was one of those partial fractions. Well, here was the integrand. Integral of x squared minus x minus 2. I found out I have to write very slowly or the pen just really screws up, over x cubed minus 2x plus 4. No, minus 4. Now, when you first look at this, or when I first look at it, I say, oh no, how do I factor that denominator? Well, the good news is, and I'll put the dx in here just to make it look right, I can factor that numerator. Okay, that numerator factors as x times x plus minus, the 2 goes with the minus, the 1 goes here. Okay, I understand that. Okay, now here's sort of a reverse of what we did before. I know that x equal -1 is a solution up here, is a solution here. If you put a -1 in for x, that gives you a -1 plus 2, because -1 times a -2 times -1 is that, -4. That's not a solution. But I also know that x equal 2 is a solution up here. With that work down here, that would be 8 minus 4 minus 4. Yes, that is a solution. So that means that x minus 2 is a factor of this. So let's do that. Let's factor, and this can be done by synthetic division. Put a 2 on the outside. This is reminding you of how we did this before. A 1, 0, because you have no quadratic term here, a -2, and a -1 there. Skip a line, draw a line, bring down the 1. That will give you 2, 2, 4, 2. Yuck. I'm doing this too fast. Oh, that's a 4 there. Okay. I thought, how in the world did that work out? That's a 4 right there, not a 1. Either my pen didn't write or something. Okay. And 2 times 2 is 4. And that gives you a 0. Done. Okay. So basically what this gives you is the x minus 2 up here. This tells you that x minus 2 is a factor down here as well. It was obvious it was. And what you have is the other factor, x squared plus 2x plus 2. Okay, because that's what you had left over here. Well, this x minus 2 and that x minus 2 factors out. Now, if you were graphing these, the still x equal 2 is not a solution. Okay, you have a hole in the graph right there because you cannot divide by 0. But that leaves you an integral that looks like this: x plus 1 over x squared plus 2x plus 2. Now that's a bear itself, okay, because that's not a reducible quadratic. So you basically have to, well, yeah, you could just go through our regular things there. That's an irreducible quadratic function, and you could just do that as a ax plus b over that, and you can go with that. They don't carry it out, so well, yes they do. Yes they do. So let's go on and do it. Okay, I thought they didn't. Here a u substitution works pretty nicely too. You don't even need to do partial fraction. Let u equal x squared plus 2x plus 1, no, plus 2, then du is equal to 2x plus 2, and that, we don't have that up there, so let's divide everything by 2, and that gives you 1/2 times the integral, and this would be x plus 1 dx. I forgot to write my dx down there, and that would be a dx over du over u, which would be 1/2 the log of absolute value u, which would be 1/2 the log of x squared plus 2x plus 2 plus c. Okay, I think that's how they leave it, or they could write it as that to the 1/2 power. Okay, all right, I think we beat that to death. Or maybe I ought to show you that last one too. If you had had this, the integral of cosine x dx over sine x times sine x minus 1. This pen is not writing well at all. Plus 1, I believe it was, wasn't it? No, it was a minus 1, sorry. Okay, if you had that, a u substitution here would work nicely. Sine x, then du is equal to cosine x dx, because derivative of sine is cosine. Yuck, that thing is so aggravating. There's your numerator here, so this becomes the integral of du over u, that's sine x times u minus 1. And then that becomes your partial fraction. So they don't carry that one any further, but that's pretty easy to go from there. All right, with all that being said, we finished 8.5. Any questions on 8.5? Okay, the concept check at the beginning of the homework exercises, good to look at. Okay, it says here, write the form of the partial fraction decomposition. That first one, let's just take a look at that. Okay, I hope you can see it. That would be 4 over x times x minus 8. So that would be 4, okay, the form of that decomposition would be a over x times a over x minus 8. That's what they're looking for there. So I'll let you play around with those. Okay, the homework exercises, though, do any of the odds 3 through 19. They're all at Calc Chat. 7's at Calc View. Either 21 or 23, they're both at Calc Chat. 21's at Calc View. Any of the odds 25 to 31, they're all at Calc Chat. 33 or 35, they're both at Calc Chat. 37 or 39, they should both be at Calc Chat. 41 or 43 should both be at Calc Chat. 45 should, I'd say any of the odds 45 through 51 should be at Calc Chat. Okay. Any questions on 8.5? All right. We don't have a lot of time left. No, we have 1 minute left. Don't think we're going to get much done in that 1 minute. What we'll do next, would have been doing next, is going to 8.6. Sorry, I didn't realize we were running. Oh. Okay. We still didn't get Ashton here, did we? I don't see him. In fact, I can't even see the, well, wait, that's more than I wanted to do there. Okay, for some reason I can't see 8.6. Okay. My share screen does weird things. It still didn't work. Okay, let me open it again. I know, I was just trying to show you what that person was and ran out of time. All right, well, I think I've already given the homework assignments to remember, and this is especially for Brandon, who came in late. You do know what happens on Wednesday, right? Wednesdays is Veterans Day. No classes. The school is closed on Wednesday. So this is it for this week. So we'll begin next week with 8.6 numerical integration. That's what I was trying to get this thing to show you, but it wouldn't come up. All right, any questions? Issues? Yeah. That's completely up to you. Like I said at the beginning, I hope I said it in every class. I think I did. What happens with that, if you turn them in every week, you've got something there. I put little pluses in your in the grade book, okay, and you get in on the Blackboard grade book, you'll see little, oh, what do they call them? It's not submissions or something like that. No points involved. It's just that you get, it indicates that you did it. If you wind up at the end of the term with more weeks that you turn something in than you didn't turn something in, and you wind up with a, say, 89.4, which normally would be a B, if you've turned in more homeworks than you didn't turn in, that'll bump it up to an A. But for most things like an 81 or a 92, well, 92 is just going to be an A, so you wouldn't need it anyway. So all it does is help right at the very end. If you're on the borderline, it may bump you up. If you're 87.3, that's not going to be close enough to bump you up, okay? But that's all it does for you. It's completely for your benefit. It's not for my benefit. It's for your benefit. If you want to turn them in, you certainly can. I'll go back and and put those little pluses in the grade book. And what is it? They call it something in Blackboard when you post it. Yeah. If you have a grade posted, even though it's a 0 grade posted, if you have more posts than you have non-posts, then that's when it, that lets you know you might be able to bump up the next letter grade if you're close enough. Okay? Did that answer your question? All right, good deal. All right, well, have a good weekend, and we'll see you next Monday. Same time, same station. Okay, well, not the same code anyway. Take care. Bye-bye. Any other questions? Got it.